Good morning, everyone. My name is Mateusz Pusz, and I am an addict. I'm addicted to generic libraries development, and I'm doing this for many, many years of my life already. You may recognize me from physical units library that I'm writing and talking about for many, many years right now. But this talk is not about units. It's about how we can improve our libraries for our users, how we can improve the experience that they have with our tools that we provide. When I was submitting this talk, I actually wanted to talk about 10 features, but it turned out that from the time that I submitted the talk and I attended a few committee meetings in the meantime and had somewhat thoughts, actually I'm going to talk about 18 of those today. As you know, C++ evolution is like, well, it's not intentional, but it looks like a TikTok approach in hardware a bit, right? C++11 was the cornerstone of modern C++. It introduced move semantics, concept, lambda expressions, variable templates, right? We got memory models and threads for multi-threading. We got range for chrono library. That's awesome for its time. It was a groundbreaking change in the language to improve what we have. Then 14, 17 were not that influential, but C++20 again was huge. Was adding concepts, ranges, coroutines. We have class NTTPs, so non-typed parameters that improve the interfaces a lot. We have concepts all the thing by Jason Turner, right? Mostly it was started with the keynote on CPCon. Const eval, really useful for compile time stuff, especially for reflection right now. Spaceship format, counting semaphore, large barrier, plenty of extensions to our multi-threading world. And yeah, we got modules, right? Yeah, we have them for 5 years right now and can't use them too much. 23 again was a minor addition, but C++26 is going to be awesome again. We get reflection, which will change the world that we know in C++. We have contracts. We have stud execution to handle asynchronous algorithms. We have even more concepts. We did all of the things before, but now we have even more. We have relocability, RCUs, hazard pointers, SIMD, lineage, plenty of new features that improve how we can write our libraries. But there are still some features that are missing that would allow us to write or provide even better experience to our users. And I'm going to talk about those features. I will describe problems that we as library developers have and which, of course, are then exposed to our users. I will talk how we can improve interfaces, how we can enable compile time code debugging, how we can have better compile time error messages because everyone complains about those, right? How we can improve safety. I will talk briefly about some text utilities that we could improve and how we can better distribute and consume our libraries. Of course, this list is subjective from my point of view as a library developer doing units. Some other people could select other features, but I still think it will be interesting for you. I will present how those problems can be addressed with future C+ language and library features. I will talk about features that were recently accepted for C++26. Nearly none of those features I'm going to talk about were actually accepted when I was submitting this talk. Right now, we shifted like 2 meetings already. We had some 2 meetings done, so some things changed. I'm going to talk about those. Though we have C++26 annotation in the subject next to the paper number. Other papers are still in the pipeline and did not get to C++26. In this case, you will see just paper number. And 1 or 2 papers are abandoned. And it would be nice actually for someone to resurrect them and work on them. If you care about it, would be nice to actually pick up and continue work. I'm not going to discuss big features like reflection contracts because, well, I have only 90 minutes and I want to talk about other things as well. Each of those subjects can be easily discussed for 90 minutes, right? And there are plenty of good talks already online, so I'm not going to talk too much about them. But I will provide concrete examples how all of those features can be used to actually improve our libraries. In case you are not familiar, this is how you can find a paper number. I will be providing you paper number, so you can always get more information about specific change, about specific proposal. You can get a paper number by just typing wg21.link in the browser. And in case of a paper, you just put P in the beginning. You can put P with a revision or without the revision. Then you go to the last version of the paper. It's really useful to find the papers if you want to find ones. If you want to actually find out what is the status of the paper, you can go to the GitHub issue with this syntax, and you will find out exactly if it's being processed, what was the voting results, or what is the status of it in the pipeline, for example, in which room is being discussed right now. It's really useful. You can also get the latest working draft for specific C++ version. And also, if you forget about all of this, you have also usage info with just wg21.link. You will have all of this information there, or even more, if you want to look for it. So this is how you can check the papers I'm talking about today. So first, let's talk about improving interfaces. Right? How do you like this interface? I see some people smiling in the audience, and yeah, this is what we are having fun of, right? This is C code, this is bad, this is not type safe. We love C++ because it is type safe language. And then immediately we type that. Or that. And actually, this is C++20 can be written this way. Or that way. Right? How it's better? Well, you can say this one fails at compile time with nice error message, right? You have just to scroll and scroll and scroll. And the first one will fail at runtime. But from the documentation point of view, from the interface point of view, provided to our customers, this is the same. We say we work with everything. Right? I strongly believe that's the problem. Unconstrained template parameters are the void star of C++. And I'm trying to improve here, although some people, even on last meeting in the committee, agreed with me about, they disagreed with me about this a bit. I was asked if I want to die for typing a template and type name instead of a concept. Well, we'll see. But I think that this is wrong. You're typing a quantity taking auto, quantity taking type name, or a function having some parameters. It's hard actually to reason about what you should have to provide here. There are non-trivial interfaces, non-trivial error messages, and you crash often the library in the implementation part of it, and you never know if it's your issue because the code crashed, but in the internals of external code, or is it actually an issue in the external library and you should submit a bug because you were able to crash their code. Right? Typically, we assume that we are the ones that did the error and try to fix it hard, but sometimes there's an error in the library. Right? So what should I pass for R and rep? What if rep and rep2 cannot be divided here in this operator? Or if this is not exposed in the interfaces? What is returned from this function? Well, auto, right? I see so many developers using auto actually in return types. Please don't. That's a really bad idea and bad approach. I know that we want to try to be lazy, but returning auto is being too lazy in interfaces. Right? Consider all of the algorithms in that library returning auto. You are going to cpfs.com, find out what the library does for specific algorithm, and you see auto as a return type. Would you be happy? Probably not. We expect types to be visible in those interfaces, but we tend to write auto by ourselves. That's not a good idea. I say that in case a library is using concepts, because if not, then, well, it doesn't use it. But if it uses concepts and I can manage to crash the compilation of this library, this is a bug on the library right away. Because if it uses concepts, you should not be able to get in with a type that doesn't actually work. It should be filtered on the boundaries of the interfaces. So if you're able to crash the code that uses concepts, it's their issue, and they have to fix it. It's not your fault. And by the way, can you spot a bug here? There's a subtle bug that many libraries have, and we typically don't see it. The problems are those two arguments of the function that look really innocent here, right? This is our type, quantity, and this is another type for different quantity. It turns out that in the language, you have different rules of how those parameters are being initialized from arguments. We call this one a non-dependent parameter of the function because it doesn't depend on any template parameters in this case. So for this parameter, you will have trivial conversions, promotions, standard conversions, user-defined conversions. All of this will be considered for this argument when you are providing the argument for this parameter of the function. The other one is called dependent. It depends on R2 and rep2, which is being deduced here. And as we've heard yesterday on the talk about the pattern matching, we learned that there is much less features that are considered for such an argument passed to such a parameter. We just may do some adjustments. We can consider alternatives, for example, base classes. And that's it. We are not doing any additional conversions. This means that interfaces written this way are not the most efficient ones. Because, for example, if I type decl type A plus B and decl type B plus A, this will not be the same. One of those may, for example, not compile because will not convert. Right? Consider that I have two objects that are convertible to quantity, but not quantity by themselves. Left argument will convert to quantity, second one will not. You can fix it with concepts. You can fix it with concepts. You can provide concepts everywhere, so you don't have type names, you don't have auto. Everyone knows this has to be reference, this has to be some representation of specific type. And I handled the previous case here by providing Q, similar to the previous case here, which was non-dependent. Right now, as a dependent name, that is constrained with a concept. I said this has to be derived from our quantity or same as quantity, depending how you want to model the new interfaces. But in this case, you have symmetric interface because those are both dependent names right now, and will have the same rules for conversion. Of course, you can even improve that as well, but this is not the interface training, so I'll not talk more about this. But this already helped a lot to provide symmetric interfaces with this concept. And also, you say that you should be able to invoke the division on those two quantities. So the representations are convertible, divisible, and there is also a return type specified, not only auto saying, but I'm returning some kind of a quantity from it. So I always try to challenge every naked type name and auto in my code to improve stuff. All right? And I said both the properties are dependent now, so this is fine. But this is about concepts. Concepts are C+20, so nothing new. But concepts is only a part of the picture here, part of the interface. Concepts specify the compile time requirements of what we can pass to those functions. There's also a runtime part, right? This is what we can do today, at best. If you're providing already preconditions with macros, you're already in the better part of the community. But still doing this sucks, right? This implementation detail is not visible in the documentation, not visible in the interfaces, in the declarations of the functions. And those are macros, right? We had contracts for a moment before C+20 was standardized, but then we decided to remove them. And finally, after 6 years, right, we will have contracts, right? This is the same thing, written the same check, but written in a different way, right? This is checked only a debug. This is checked however you want to spell for your build. You may specify that you want to totally ignore this fact and have undefined behaviors if you care about performance, but you may have builds when you actually check everything and verify if everything works fine. Contracts will be great. They're already in C+26, and they will improve the way how we talked about interfaces. Finally, we can talk about compile time and runtime restrictions to our interfaces, which is so huge for everyone, for users, for developers, and for many other stuff, because also performance may be faster, compilers may do some assumptions based on this. This is laying the base ground for many, many interesting optimizations in the future. So I'm really excited about this, being able to finally provide all of the information about the interface in its declaration without any documentation. It's really nice. Another interesting feature, the really important one that was added in C++20 was class types as non-type parameters. 5 years ago, at this conference, I was saying that probably it's one of the most significant improvements in the template metaprogramming during the last decade. If a template parameter behaves like a value, it probably should be an NTP. At this point, I even didn't realize how much they will impact my library. I had some ideas that they are great, but I didn't know actually where I will end up 5 years later. So those are the current interfaces I have. In one line of the code, you can specify information about the, for example, dimension, quantity spec, unit, provide some prefixes, and then you can write the type this way, quantity of speed in kilometer per hour. This is mind-blowing comparing to what you could do before C++20. Right? If you know stud ratio interfaces, stud ratio multiplies, stud ratio divides, and so on, this is so much better. And all of those are actually NTTPs. Every single template parameter you see on the slide is NTTP. It was not the case when I was showing this previous slide with my talk 5 years ago. Right now, every single parameter is NTTP. You can pass strings. You can provide all of the arithmetics here and pass NTTPs to your classes. That's really, really nice. So NTTPs in C++20 are defined as being of structural types, or auto or citat. And structural type is defined to be a scalar type with constant destruction, alpha reference, or literal class, so the one that can be used in concise functions, where all base classes and non-static data members are public and not mutable structural types. This one thing, the public here, bothers me a lot. It was a trade-off, I know. Otherwise, we will not get them in C++20, I know. But still is inconvenient, really, really. A big problem. I will show you why in a moment. So this is similar stuff. I'm providing thermodynamic temperature, the dimension for it, the quantity type. I provide some origin, specify that Kelvin uses this origin, absolute 0, right? And I specify delta, calling this a point, absolute 0 plus delta. Is actually the ice point for Celsius scale. And notice that I can put that point that I calculated here to a template again. Claim me this ice point and then specify the degree Celsius unit to be based on this ice point. And I can write 21 degrees Celsius. What does it mean? It means that the quantity that I specified here is embedded into quantity point, which is embedded in the point declaration here, which is embedded in the unit declaration here, which means that those higher level abstractions are put again in the unit's definition, which means those has to be also structural types, which means they have a public member. And you can access it in my library if you really, really want to. I struggle a lot to provide safety to my users, safety for proper interfaces that make sure that all of the values are handled properly, that scaling is done correctly, and they have access to my public member. Because I have to, otherwise it will not be possible to put them in the point definition. That sucks. And actually users start to use it. For plenty of time, I'm like grabbing GitHub, looking for the users of my library to find out how users actually use my library, to maybe improve, to provide some feedback. And I found out this PR in some library saying, we had ours number, but I removed the number from the, or refactored this to a longer function in the version 2. So they started to use numerical value member inside. So I said, well, you should not do it. They should not be used directly because they're implementation details. And I said, maybe I should somehow obfuscate the name to discourage people from using that. And I got the answer that, well, I don't know if obfuscation would be effective because, well, Doxygen comments maybe will be better because, well, they pop up in my IDE when I press dot. So I always see them. Right? IDEs show those public members, which sucks. In the static library, of course, we can say, well, we can name them with 2 underscores. 2 underscores should not be used by users, and they are on their own when they are using, because they know they shouldn't. But as library developers, that I'm not in the standard library, I cannot use 2 underscores. So the only thing I can do, I can make really nice and long name, so people don't want to use it. And that's what I did. And I plan to change it every major feature, so people don't depend on it.
The hashing.
This sucks. So authors of C++ classes that want them to be usable as NTTPs have to sacrifice encapsulation, right? Also, there are plenty of types that could be useful in compile-time contexts, like optional, variant, tuple, span, vector, but we can't use them because they have private members. Even if my quantity type has public member, so it's compatible with NTTPs, if I will put something for rep here, like, for example, uncertainty type provided by the user, and uncertainty has private members, immediately my quantity will not be possible anymore to be used in an NTTP context because it uses other type that is not NTTP friendly. So it still affects me. Also, we wanted to have basic fixed string, or fixed string, basically C++26. I wrote this paper, and it was postponed until possibly next cycle, C++29, because we hoped to fix the language, and we didn't for C++26. So we didn't get it in this release because we were waiting for some changes that didn't happen in the language as of now. We hope that we'll be able to provide in-place string instead of fixed string, which would be much more useful in case the language changes. But we need this to work as a structural type, so NTTP-friendly type. The proposal that was rejected for now, or rejected, postponed, let's say, it's not rejected, but we said, as always, do more work, was by Barry Resvin, really nice proposal that wants to extend support for class types to non-typable parameters. The idea is that you have to provide 2 functions, to meta representation and from meta representation, that basically use reflection to convert them in NTTP context properly. You have to convert them both ways to make sure that they can basically be used efficiently. But in most cases, the default provided by the compiler would be enough. Those 2 lines will basically save all of the issues I'm talking about right now. This proposal is still in the pipeline. Hopefully it will progress. And this is what you will have to add to your classes in order for them to work fine with NTTP class context if they have private members. In most cases, as I said, this should be default. In some cases, you will have to specify exactly which members should be treated in which way if you want to basically implement them, because this is like a serialization of your type. Really nice proposal. I really cheer for it. Hope that it will be accepted for the next standard. All right. So probably some of you already had this issue. Do you know what may be the issue with this code? I have some concept constraining queue here, and I have a forwarding reference of this queue. Any ideas what may go wrong here? The comment for this is that, do I really want to write forwarding reference? Yes, I want the forwarding reference because I want to pass quantity as efficiently as I can. But forwarding reference has this strange property, or the powerful property, that actually will be able to propagate everything in a perfect way, right? So it will, if you pass reference, you will get reference. If you pass const, you will pass const. And then this queue will have those const and the difference in the type, which will not match typically a concept you want to compare. That's why it's a common problem that if you're having foreign references, that those types will include references, const, volatiles if needed. So typically you have to write remove cvref on this to verify the concept. That's a common pitfall, and sooner or later you will find it out that you have to write things like that. Another thing that bothers me is that, for example, if I have some, for example, when all algorithm, for example, in coroutines or senders receivers, I want to pass away tables. I expect that R is a range of away tables, and I have to provide range value T on the range, spelling this in away table in separate line. I cannot do this in one line because I don't have access to R and its values in the one line. So I have to write another line in my in my interfaces. Right? So for many use cases, you cannot just write one line with this shorthand notation. You have to provide additional requires clauses to constrain it even more. So basically, those things do not compose properly. Another case is here. I use treat as floating point. This is from Chrono. This pattern from Chrono is being used there already to say that I'm extending my floating point type trait to my custom types because you are not allowed to specialize its floating point for a custom type. Basically, most of the type traits from the type trait header cannot be specialized for custom types. So this is how we are cheating by providing another type trait you can specify for my float. And then I have some predicate called Olaf. I say I take some predicate and apply with for the expression this predicate to my types. This doesn't play nice. Right? This is type name, so it needs a type. This is bool, so it's a value, variable template. You have predicate, but it cannot be used here. In order to make it work, you have to actually create another predicate being a type with bool constant, call it _t, and then you can pass _t here, which is a boilerplate, which is doing more, which increases compile times, which makes also people confused why you have two of them. But this is how you do it today. It's also slower to compile, right? So this really nice proposal that actually was accepted to C+26 already, that allows you to create concept and variable template parameters. So instead of writing this, I can create decays to concept that will take a concept template as a parameter, which was impossible before. And now my two lines can be written as decays to quantity auto-refref. Shorter, nicer interface saying what is it about to. Or I have this when all for my array tables. Instead of writing this, I can write range of, where I take another concept template, and I say it has to be a range, and the range values should satisfy this predicate passed by user. And I can write when all range of away tables, away tables. I like this much more than this one. Right? Those are really nice, small additions to the language that make the language more generic and more consistent. Because why type templates were only privileged in the language? Why not variable templates that are in the language for more than 10 years right now? Concepts are for 5 years, also not allowed. Now, it's truly generic in this case. Actually, I talked about this 4 years ago already and provided the first paper about this. Then it was taken over by some really nice guys from the core group, from the language group, Corentin, Gasper, and they continued the work in order to make it work. And now it's in the language, which is great. So, for example, I can write Olaf, right, with some predicate being type. And I needed this one before. So now I can write auto, not only concept, but also auto, which will take a value. And I can just pass my variable template directly without providing additional X abstraction that will just make things slower to compile and provide additional things. And now there is a question. Because I have two of them, type name and auto. Which one is better? Why do I have to choose? Can I have both? It turns out that in the language, we have three template parameter kinds. We have types, we have non-types, so values mostly, and templates, so the generators. Those three are provided in the language for a long time already. So if I want to actually write all of algorithm for all of the cases, I have to write all of them here. This is the one that takes types. This is the one that takes the predicates that is for types, predicate that is returning values, and concepts. And I initialize it with types. I may have also a predicate that takes types, values, the predicate for types, values, and returning the type, value, and concept, but taking a value. And you think that's bad already? It may be worse. Because you may have predicates that do the same, but which takes value, but expects a type. So you want to do declare type on each of the arguments passed, right? So if I pass a value, I take the type of the value and then pass it to a predicate to verify what I'm returning, right? In case of types, I always do colon value in order to compare them. Otherwise, for a variable like bool, I just compare them. For concept, of course, concept is a predicate by itself, so I just compare them and do some logic. And I'm so proud of me. I just I handled all of the cases, right? 9 different versions of the same algorithm with different names. And then the user comes and says, I want this to work. I'm passing you integral, which is a concept, and I want this type and the value and type and the value to work. As of today, it is impossible to specify a pack of different kinds. Because say I either have a pack of types, or have a pack of values, or have a pack of templates. You cannot say I have a pack of mixed kinds. It's impossible to implement this either unless you will be writing each specialization for each parameter by yourself, so pre-C++11 era without variadic templates. So, yeah, this is me. So for 5 years, I'm talking already about universal template parameters and provided also the first paper about it together with Gasper. And again, it was taken by the language group later on because I'm working on units. I'm not the language guy, so again, Corentin and Gasper are working hard on this, but it's still not the part of C++26. Hopefully it will be part of C++29. We want to introduce a universal template parameter, saying, this is a template parameter, but I don't care what is the kind of it. This is just a parameter in a template. So you may say, I have 3 generic Olaf that takes a predicate that returns anything, that basically is either a value or a concept or a type. And it takes anything as an argument for the predicate, and I also pass anything as arguments to be passed to this predicate. And I can do this for this expression here to write this Olaf. It uses check here as an implementation detail. So what check does? Check just passes the predicate and arguments to this implementation, and in case I need a type in a predicate, but I get a value, I just declare type this value to get a type. And I have another helper, check impl here being used. And check impl just calls the predicate with the argument. And in case the argument is, sorry, the predicate returns a type, then I'm returning value from it. And with this, I am done. With this, I have truly generic all-of finally done for all of the possible inputs. I may have all-of scalar, double, float, long, double, right? So the class template, a type trait from the standard library, taking types. I may have variable template that you've seen before, taking types. I may have concepts taking types. I may have concept taking and testing the values, non-negative. I may have concepts taking anything, type, value, type, value. I may have concepts taking values, because those are values in my library, second, meter, meter per second are values, as you know already, but they are compared against their type, if they are a kind of unit. And similar for here for quantities. It takes anything, because it's a value, this one is a type, and can say this is a quantity. That's really powerful. Being able to write this all off in one unified interface for all of the use cases, it's a really benefit for many things. It was impossible before, as I proved, to do this right. Already, the previous slide was really cluttered with plenty of different options, and it didn't cover all of the possible scenarios. Another really useful type trait you can implement with that, we can write finally specialization of, saying this is specialization of, so probably it should be a type name, but you can choose otherwise, but it takes any parameters. And then provide specialization saying that this should be, in this case, it's true, if it can be specialized here. And you may have a concept called specialization of. And I can write specialization of vector or array, and I don't care that array also takes a size, which is a non-type, right? It's a value, for example, 5 or 32. It just works because it takes universal parameters, and I don't care if there are types, non-types, or generators. Another useful type trait that we can get inside the library when you have this feature would be derived from specialization, which is really similar. I will not go through the implementation exactly. You can find it in my slides, but works exactly the same. You may say that something is derived from specialization, and it just works for any class template you pass here. Really powerful stuff. Also, in my talks, like 5 years ago at this conference, I was showing this interface for different units. Maybe it's not that visible here, but basically I was showing that I need class templates with different names for different scenarios. If I had this universal template parameter, I could provide the same class template name for each scenario because I can specialize it, saying it takes any parameters and then provides specializations for each of the scenario. So it's similar to function overloading. Consider function overloading and C-style functions having the different name for different use case. You can do the same with class templates right now and specializations having this parameter. The same exactly name of the class template handling different scenarios rather than the previous version when you had class templates for each scenario separately. So you have here named deduced derived unit, named scaled derived unit, coherent derived unit, named coherent derived unit, deduced derived unit, prefixed derived unit. Who will actually grasp it and know how to use it properly, right? Here you just have a derived unit, and you just provide proper parameters, and it works. So I really feel that this feature that is still missing in the language, it was considered for standardization in this phase, but still more work is required by the language group. Or requested, maybe not required, but requested, because actually we have working implementation of this in the compiler already. I think it's a cornerstone to building truly generic interfaces, as I proved you in some cases here. So coming back to variable templates. Variable templates are preferred in many modern libraries over the class templates because they are less to type and faster to compile. So this treated floating point that you've seen before is implemented this way, just as a reminder, right? I have treated floating point. I'm using here the type trait for it, and I can provide specializations for my own type. However, for some cases, there's no good default for the default case. I may say, for example, Unicode subscript number for 0 is that. Up to 9, it's that. But what should be the default for the value between 0 and 10? right? In order to have specialization, I need to have a primary definition first. In class templates, you may say just semicolon and don't provide the definition. In case of variable templates, you always have to end up with something. There's no good thing to put here. That's another issue. There's a paper that actually is abandoned. I don't think no one works on. I think that no one works on it right now. I would love someone to actually work on this one. Just allowing you to write delete in this place, saying this by itself doesn't have sense. Only specializations have sense. It would again allow us to provide better, faster to compile customization points. Another case, I may have quantity points for latitude and longitude. Those use bounded types, right? Because the latitude is bounded on 90 and the longitude is bounded on 180. So you can go from around the world and basically the number will wrap. And when you're having longitude and latitude, if you are far from those two different locations, then you cannot just calculate straight line between those, right? Calculating straight line through the middle of the Earth doesn't have sense. If you want to travel from New York to Tokyo, right? You have to do it with this fair approximation. So this is how we do it. And we are using here sinus, cosinus, and so on in order to make it work. I'm using SI degree here. And then actually have to explicitly include sinus, cosinus, and other functions from the SI namespace in order to make this work. Which is confusing, because if I have SI in this class template, I should depend on ADL to find those. It turns out that someone, I don't know exactly who, but many, many years ago, said explicitly that in case of the argument-dependent name lookup, we just use in-class template specializations, and we look for the types of the template arguments for template time parameters. And there's explicit note. Non-type template arguments do not contribute to the set of associated namespaces. So someone explicitly decided not to use NTTPs namespaces to use in ADL. This is why in this code, when I use SI in my class template, I will not find sin when I'm doing unqualified lookup to basically find this function. I have to use using declaration, which sucks again. So also, like a few years ago, I asked the question why we can't have nice things. We have either to allow these interfaces that we agreed they are really nice, but they don't use ADL, or you have to use decal type of this expression in order for ADL to work, which sucks from the user point of view, to spell those all the time. Constant wrapper that was standardized for C++ also has this issue. They solved it by the fact that they provide first the value, and then they have parameter that the user should not specify, but the compiler or library adds it by itself by just doing decal type of the value provided here by the user. With this, we have a value and its type in a type which makes ADL to work. I could use the same in my quantity, but you don't want to see in my quantity type in an error message, for example, meter per second twice, once for a value and once for a type in the error message, because we want to be terse, we want to be nice to read. We don't want to repeat information just to make ADL work. And even then, they say that it will break without any parameters, and also that the support is still imperfect, because in some cases like this one, it will not work at all. So it's just hack to make something work. There is a nice paper that was proposed for C++26, but again, committee asks for more work, where you can specify explicitly which namespaces are associated with your class template. So this you may say, I'm associating namespaces additionally with the types of of this non-type parameter. And this will solve my issue with scene, because assign degree will be an assign namespace here. I will take declared type. I will say that this namespace is associated, so to be looked in ADL while this argument is being searched for. Also, ADL is the source of many, and unqualified lookup in general is a source of our compile time issues we have. We typically blame templates for compile times, but it's not the case. Typically, overall resolution and name lookup is the hard thing to do. And this was really visible in the senders receivers. They use plenty of hacks in order to fix it, but with this proposal, it's much easier. You just say, I am not using ADL for any of the parameters of the sender. And as you know about senders receivers, they basically nest and nest and nest and nest. Entire program can be a sender. So all of the namespaces you use in the program can be in this type. So standard library, namespace, boost, Qt, and possibly your production namespaces as well. So if its entire program describes one sender, then all of the possible types used in the entire project are in this type, which means that all of the possible namespaces are being looked with ADL all the time if it's not done right, which will affect your compile times and possibly provide also some ambiguity in case you have collisions of names. That's why this feature is so useful. Being able to write that would be really nice to improve compile times and remove all of those ambiguities, because typically you don't want to customize based on this. It's just how ADL is being done by itself. You don't have to opt in for ADL, it's always there. Or another example, you have array map. You may want that, say that I want to customize array map based on the type tip provided, but not necessarily about allocator that's in the standard namespace. So I don't want to look in the STD for overloads, customizations for my array map, just because there is stood allocator. So I say only this first parameter will specify the customization, but not the other one. So this is nice. Another interesting use case. In my library, for example, when I type kilogram times meter and meter times kilogram, I want to end up with the same type. Otherwise, it will be really hard to reason about and actually provide the logic for the library. Right? So if I do declared type on both of them, I should have the same type. So I have to order them, right? This is the type actually I'm generating, direct unit of kilogram meter. I decide that kilogram should be before meter in the type, and I'm being consistent and always do this the same way. To do this, you need a predicate and some type list sort helper, right? It just has some implementation. I will not show implementation because it's, well, the beta programming stuff, how you do proper implementation of sorting, but you provide a predicate that takes two types and provides a type as an answer. And then I may implement a function called type name that returns me string view for specific type t. And I can say that I have type name less, which is a bool constant of type name and type name compared with less. And then I can check type list sort of type list BAC with my type name less should return me the same type as type list ABC, because it sorts all of the elements. So such sorting is useful in many cases in my library for sure. But how to implement this type name function? Today, you can only do that. There's no standard way of doing this properly. This is a hack, right, to make it work. But it works for my library on major compilers. So this is my case. However, I noticed that when I add anonymous namespace and I add some unit there, and I implement this, then, for example, on GCC, I will get direct unit of anonymous cows. On Clang, I will have direct unit of anonymous namespace cows as a meter, because they actually tend to compare them differently. So it's not that standardized. Right? So the I cannot provide like portable interfaces for such units defined in an anonymous namespace. And it already bothers me a bit. On last meeting, 2 days ago, or 3 right now, 3 days ago, we accepted this feature. We have standardized concept type ordering in the language right now. And you can just pass type order to my predicate, and this will just always compare properly in a portable way between types. It's useful for me, but not only for me. For example, you may have typesets, and typesets of AB and BAA should be the same because you don't care that there is a repeat of A. You may be doing this explicitly or implicitly through aliases, right? If there's the same type twice, you want to merge those two together so there's only one entry and the same order. So all of them look the same. It's useful for some logic of the libraries, but also for compile times. Because this and this have exactly the same behavior, but those will be two different instantiations of the same class template, which basically is more work for the compiler. Another possibility is where you have policy-based design. Again, you specify some type T1, and I can imagine that in the same project, people will spell it a few times, and they will use the same policies, but in a different order, which will yield different specializations, which will again take more time to compile, and possibly will complicate the logic. Like for example, comparison operator will have to account for arguments being possible in different orders, even though meaning the same. Or a variant, right? Variant is just a union. I should not care what is the order of parameters specified, and variant is really, really slow to compile. So if you have variant of int and double of int, the same variant, you have two large instantiations of plenty of templates just to make it work. All of those features can be right now written in a nice, better way using this really small addition as it could be seen by some people. Right? We all care about compile times. You may say features like this are not useful, but for library developers, they're really important to provide a better experience for you. So you will have better compile times and less instantiations in your binaries. One of my recommendations when I provide workshops to customers, I always say, always use constructor initializer list to initialize your class. This is a good default. It is like the rule of thumb, right, to initialize classes. Well, it's even better to put this as a member initializer list if possible, and don't write the constructor at all. But if you have to write constructor, use initializer lists. But then, for example, I have to write measurement in my class template. And as long as I can set the value here, I'm not able to initialize the uncertainty, because uncertainty should be the ABS of the error provided here. There's no way for me, well, maybe without using lambda in the initializer list, to say I have to first do using directive here, and then, or using declaration for ABS, and then only do it with unqualified lookup to look for customization points that are potentially done for a specific value type. So I have to use it in the body of my constructor rather than initializer list. Also, when I implement this ABS function in my library, I have to say that I require, of course, I have to use using here, right? This is using declaration done properly here, and unqualified lookup. And I want this to require that this code below compiles. And I have to use both options. Either I'm using unqualified lookup or qualified lookup in STD. Having to constrain it this way sucks again. I don't want to be forced to write those two. There's no proposal on this, but if you care, it would be nice to come with a proposal to introduce customization point objects for mathematical functions. With customization point objects, like we have already swap, begin, and many other customization point objects in the language, you could also have customization point objects for ABS or some other numerical functions that you could specialize for your own custom types, like myInt, myFloat, short float, and so on, right? There will be more and more custom numerical types in the industry, also for safety. You will have safe integers, safe floating point numbers, to prevent overflows and so on, because we have pressure from the community to improve safety of our libraries. We will not be able to fix the fundamental types in the language, so we can provide safe wrappers. So more and more types will need such customization points. So being able to use customization point like this one, for example, math ABS, would be really useful. Right now, as I said, there's no proposal on this. So if you care, it would be nice actually to come up with such a proposal. I also care, but I'm doing other stuff, so I will not do too many things at once. Maybe when I'm done with units, I will try to approach other things. But if you care, it would be nice actually to propose maybe such customization point objects in order to provide better look and feel and customization for many different projects, right? And then you can have more power, not only do ADL lookup, but you can, for example, check for member function and non-member function, and then in the end for STD, in case it works with STD, right? And of course, you can check also return values here also. So more power to ensure that ABS is not broken, because ABS returning void probably doesn't have sense. Right, so with this, I had this before. Right now I could write it this way. Just I require math ABS and math ABS to work here. And this would work really nice. All right, let's move on. Enabling compile time code debugging. How you can debug at compile time, how we debug at runtime. There is one really popular way of debugging, printing stuff, right? Lots of people print stuff. Of course, we should use debuggers, we should use undo projects for debugging, right? Yes, but at compile time it's hard. There is no compile time debugger, so we can only use this easiest way of debugging with printing. Traditional code debugging of concepts is hard, because if it happens at compile time, you cannot breakpoint in a debugger. My library, 90% is const eval. Debugging const eval is impossible because there is no binary. Those functions do not exist in a binary. When you launch debugger, there is no function anymore. This is tricky. And the logic may be non-trivial. Trying to find out why something doesn't compile may be scary. So with this proposal, still not part of the language, you could be able to provide prints that are visible at compile time for specific branch and know which branch was triggered in specific logic, which already will be a huge improvement for compile times. Even there is a possibility to specify tag that you can select at compile time in the command line, for example, that will enable and disable specific messages. How do you like this interface? Stud format allows you to write this, and this is valid. Right? There is a bug. Do you see a bug? There is one car is missing. But it's okay. It cannot be triggered as a compile time issue, because in some internationalizations, so if you want to internationalize your code, it may turn out that some parameters will not be useful, or you have to provide more parameters for some specific languages. And that's why you may have more arguments than actually are being used in the format here. And depending what kind of developer you are, you may be either scared, surprised, you may say, oh, that's funny, or yeah, this is for geeks, right? And I see each kind of such face in the audience right now. However, most users probably would like to diagnose such issues. So you can provide things like that in the code of format. Context warning, not print as before, but warning. Provide a tag for it with a message. And then at compile time, you could enable them with -w and w no. And you can have those errors, warnings from the library code being detected by your toolchain. which is really nice, right? To be able to add something to the warning list in the compiler. And of course, there's also a version for errors. You may say this is context error, this is hard error. You can, of course, have option to possibly overwrite it as well. But with this proposal, you can provide prints, warnings, and errors on different levels, which is nice. So this leads us to better compile time error messages, right? Who thinks that compilation error messages from generic C++ libraries are short, easy to read, and understand? Hands up. I don't see any hands up in the audience. And you have a full room of people. Thank you for coming here. This is what I shown like, when was it? 2019, wow, 6 years ago. This is the first line, actually not all line fit on my slide, from Boost, when they have an error in units. First line didn't fit on the slide, and there are plenty of lines. All right, this is what we deal in generic libraries often. But it doesn't have to be the case. We can do better already. Right? If you use concepts, if you think about error messages, this is how you can write a quantity. With concepts, there are some reference, quantity spec, unit, insight, representation, and then you have function in, and plenty other functions. And if you specify that in function requires us for the unit to be a specific quantity type, so for example, new unit should be the same as new unit should be a unit of length, for example, and the conversion should be value preserving, or the scaling should be value preserving, then you just write the code here and what it can bring you. If I will say, I have a unit and I'm passing a quantity type, which is totally nonsense here, I will get this entire error message. This is it. I say that no matching function for call to in, and I have 3 candidates. Candidate that has 2 rep. This one doesn't specify rep, so it's out. I have temp parameter that doesn't take any arguments in, so this is also out. And I have third candidate with constraints not satisfied. Right? So we have 3 overloads, and only one of them is possibly analyzed. The rest are out right away because this and this is not correct. So if you're looking into this constraint, we see that unit of basically that the unit of time is not the one that's being used here for the quantity spec, because we are using quantity spec of length here. And you can see this here that is basically checked in this case. Right? Sorry, not in this case. I'm wrong. I didn't see correctly. Yeah. So I'm saying that ISQ time is not a unit because it's not derived from the unit interface, because it's not a unit, it's a quantity type. Right? I was talking about the next slide, sorry. So you have a nice error message, short one, with possibly one additional verbose line here that is not useful. Because if you say that derived from doesn't have sense, then saying is based off probably doesn't have sense as well. But this is implementation detail of how it's being implemented. You can get rid of the implementation details if you want as well in your compile error messages, but this is STD derived from, so I cannot get rid of this additional line. But you could with some indirection. You could use variable template, or you could use a function and then just hide it as an implementation detail inside. And the compiler will not basically expand this. So if you have quantity limiters and you pass seconds, so this is the case I was trying to describe before, you have even shorter error message. You have this first overload and the last overload removed as well as before, and this second overload says that unit of evaluated to false, because the quantity spec of seconds is not kind of length. Right? Seconds is not length, so this is the entire error message. And that's it. Of course, I love this Clang output. We have an internal competition in our team who will find an error message with the most braces included. I submitted this as a bug for Clang, still not fixed. Hopefully they will fix it at some point, because instead of this, they should just print length, because the type of the struct length is length. Well, instance of struct length, right? This is creating instance of struct length just to take the type of it, even though they have it here, and then create an instance of instance of instance of instance. So this should be just length instance. I would say this is quite nice. Also, this could be a bit improved because you have the application of information here, because this is what the code does, and this is how the compiler sees it. Quantity spec of seconds actually is not that useful here. Actually, if it was evaluated in this case and left in this case, like that, the error message would be even more useful. Right? Saying kind of time is not convertible to kind of length. But still notice that even with the original message, it's not that hard to read and understand this entire message. I'm not hiding anything. Well, I'm hiding the prefixes of the path before error and note, because I don't want you to actually see how is my code structure on the disk, and it doesn't have sense in this presentation to show it. So I just streamed the prefix of every line here with the path to the file. But otherwise, it's entire message, exactly like it's printed in the compiler. Generic error messages can be really nice if developers care about it. In many cases, in some it's impossible, but in many cases you can optimize and improve. Well, that's why I can't. Yeah. Third case. I have meters and I want to express this in kilometers. Again, first and third one goes away because it's not the case here, and the middle one says concise not satisfied because there is not value preserving conversion from unit to kilometer for the specialization type. Because it says that treat as floating point for int evaluated to false because it's not a floating point, and meter to kilometer is not an integral conversion factor because it's dividing by 1000. Again, this is entire error message. All of the implementation details of how it's being verified is in integral conversion factor in this function, because providing all of those things why and how I check this will not make you have more information from the command line message, the error message, compile error message, because it will just be implementation details. You don't have to see them. This message is enough. And if you optimize for that, you can provide really nice error messages to your users. Right? So we complain, but actually, most of the libraries can be better already. But let's see how we can improve it even more. And of course, it assumes you're using a good compiler. I was using Clang 20 all the time. This is GCC. This is not that nice anymore. GCC is much more verbose, right? It says there are 3 candidates. Candidate 1, candidate fails because of constraint not satisfied. Candidate 2 fails because of the 0 arguments 1 provided. And there is also candidate 3, where temporary argument deduction substitution failed. This is a lot of information and a lot of characters to be read. I prefer Clang error messages. Also, let's look into this middle one. I will just zoom it. You have mentioned that temporary argument substitution failed, constraint not satisfied, and then you say that because this thing doesn't work, but you don't know exactly why. Because it says if you don't want to know why, you have to extend the error message even more with an option. Right? So probably the most important information actually is missing here often. You have to use actually this f-concept diagnose depth with more to see longer error message. So it's not that helpful. Clang is much better in this case. All right, so let's see how we can improve. Instead of having constraints on the interfaces, I may say I'm having some more generic checks on it to say if it's unit. If it's not unit, then well, it's obviously wrong. But I'm doing additional checks as static asserts in my function here, function template. Right, so I move those checks from the interface to the implementation. And implementation right now interface just says I take a unit, any unit, and I'm doing checks inside with some nice error messages. So with this entire message saying, well, not entire, I have some dots here. I will show you why later on. But this is the error message that I see in the top of the compilation error, saying assertion failed, not value preserving in the first line, which is nice. All right, and then I have information why it failed. Actually, there is a proposal that was accepted for C++ 26 that you can provide your own static assert messages known at compile time. We still don't have ISTD formats to work at compile time. That's why I'm using FMT here. This is a trick to make FMT to work at compile time. I have concise format, FMT format 2, and then I can pass the format spec and unit symbol here to concise format, and then pass it to static assert as your generated message, which makes my error message even nicer. Static assertion failed. Scaling from meters to kilometers is not value preserving. At compile time, using FMT. Really nice. And there's a proposal for concise stud format, but still not in C+26. So concise stud format, I will just be able to write stud format instead of FMT to do the same. With reflection, that is C+26. Actually, I should mark it as 26 on this slide, but it is 26. I can use this display string of to get nice string for the type. Here, here, and here. And then error message will be scaling from meters to kilometers is not value preserving for int representation type. Even better, right? We improve. But let's come back to those 2 errors generated, because it's only one of the errors, and there are 3 dots. The second one says there's no matching constructor for initialization of quantity, and 129th line more in clang, which is stairs in general. What happens? I have the static assert, and I have this quantity of auto return type. Compiler really tries hard to deduce this return type, even if there are static asserts inside. So it calls this constructor anyway, besides printing those asserts. And of course, if the input is wrong, this constructor will fail. And this is why we have those error messages trying from the constructor initialization. The entire idea of having constraints of this function was to not pass incorrect input to the quantity instantiation here. And we just did. Even the static asserts are here. Another problem that I see with static assert is that plenty of people will write code like this one, saying, let's try to convert this kilometer, this quantity to kilometers. And they write it this way. If in is successful, call in. Otherwise, don't convert. Right? So they depend on my checks to verify if you can do this operation safely without truncation. If it's possible, then they convert. If truncation happens, they say, oh, I shouldn't do it, then I will stay with the original unit. That's a valid use case. But to static assert, instead of this compiling fine and just decay to Q, it will just be hard error. When you try to do this in here, you have static assert saying it's wrong, and the call to not compile. Alternative will not be selected. This is a generic problem with static asserts. Static asserts are not good for generic programming. Static asserts are good to unit test your compile time program. Static asserts are good to possibly verify some invariants of your class. For example, is trivially copyable? It's a good check below a class if you intend to use memcopy on it, but not to verify constraints. And I've solved this problem already many times. This is one of the issues I've seen, for example. In one of the user types I used for my quantity type, I actually submitted an issue to the authors. Do not use static assert to prevent template citation errors. It turned out that what they were doing, they had class template, and inside of the class template for linear algebra, they were checking with static assert if the dimensionality of this array or matrix has sense. And the static assert was triggering for me when I was doing some totally unrelated code. What I'm doing here in my code, in this line, I just check if I can use a wider type and check if I can multiply and divide type, then I'm using this wider type. Otherwise, I'm using int max. And when for this v, so basically type t being used somewhere, or the rep here, when I use this linear algebra type, this thing generated something that had invalid dimensionality. So the static assert fired, and my code didn't compile with this project at all, instead of just decaying to the int max. Also, if you are using proper constraints rather than static asserts, you can do negative unit tests for your things. Because I don't know how many of you actually are using concepts already. Hands up. More than half of the room. How many of you do unit tests for negative scenarios? Much less hands. Right? This is also a part that you should test. If your constraints are actually provided properly, not just constrained for fun. Right? And this is how you can do it. I say I should not be able to instantiate my quantity class template with this and this and this and this because I constrained for this and this should fail. If I do static asserts in my class, I will not be able to test it because I will have hard errors in every single case in this unit test. As I'm using proper constraints, this just fails to be instantiated, and my compile time test says this cannot be compiled properly. This doesn't instantiate. All right? And I have proper negative tests for concepts. So introduction of requires expression made it so easy for everyone to start playing with those compile time logic. You don't have to use void t enable if anymore, which was quite tricky. And static asserts works against it. So I'm not recommending doing that in such cases. All right, so static assert is a wrong approach. Maybe let's try this context error stuff. And there's also a proposal to extend the context error to actually have not the string as an input, but actually FMT-like interface, but only when actually context format is accepted. Then you'll be able to just write the format specification here and parameters, and it will just use FMT under the hood, which is nice. But again, it will not sphin properly. So let's try to throw the same thing. When I'm trying to throw it, I have the same issue. I'm trying to instantiate the return type based on this thing, and I'm passing incorrect input. So I have still a long error message saying I cannot call a constructor. So it's not a good idea in this case. So let's try otherwise. Instead of having throws in the body of the function, let's put throws to the constraints of the function. So what I'm doing here, I created some custom exception type, and I created a helper called unsatisfied that takes a format as compile time string and passes arguments to it from the function arguments, and instantiates basically this expression type. And I can write my value-preserving scaling as saying it should be some same scaling. It should be treated as floating point, integral conversion factor, or so it will be triggered only when the beginning is false. When this is false, only that this one will be triggered because there is short circuiting on the constraints evaluation. Unsatisfied with this format message and those arguments, we just throws an error. It will be throwing an error only if this is already false. Right? And I can write this value-preserving scaling here as a constraint, and then I have nice error message. I have explanation that substitution into constant expression resulted in a non-constant expression here, while checking satisfaction of the concept, and I get the information that I'm trying to throw, which is not a constant expression. It's a bit better, but still not really nice. In C++26, we got a new proposal that was accepted, that we allow throwing an exception. So it is a proper constant expression when it's being thrown. And those are the motivation examples from the proposal, saying that I may have a const eval function that takes some string view input. If input is empty, I can throw an exception. Otherwise, I will do concat, which may also throw an exception inside. If I pass empty, well, before I had always the error message at this point saying I cannot use throw in a compile time context. So if I pass empty parameters here, I go into this branch tries to evaluate throw, and I have compile time error saying you should not throw because it's not context friendly. After this proposal, this is fine. So, but in this case, you will have an error message in this place at call site saying that there was an unhandled exception in your compile time logic. So rather than throwing the complaining about the throw site, you have information about the exception leaving the compile time context. In this case, it will work fine. If you do try and catch for this, it will be fine as well. So this is an improvement, but still not Spinner friendly. I contacted Hanna Dosikowa because Hanna proposed those things, because Hanna cared a lot about context. And in 3 hours, she was able to provide me a compiler that had a fix for that. And then provided a paper called Spinable Context Expressions that was discussed on the last meeting, but again, more work was requested from the language group. With this is my entire error message. Not for C++26, unfortunately. I'm really sad about this. I'm even eager to submit a national body comment for that. Still consider this. Because I think that right now, context exceptions are fundamentally broken if they are not spinable. The question was from Jason. I didn't hear it. Was it accepted? Sorry, I should repeat the question. So we have no magic member function to call for int, and this was the first overload. Last overload, as always, that was failing, and the middle overload saying that constants are not satisfied because value preserving evaluated to false because this throws an exception, and we have scaling from meters to kilometers and value preserving for interpretation type. This is already really nice, and this works on this compiler from Hanna Dosikowa, and also with my library on top using FMT. You can try it out, you can play with it, and see how the error messages looks like. It's really nice. I would refactor this a bit because Hanna provided some shortcuts here because she actually removed the logic why actually this unsatisfied branch was selected. And also, this exception message should bubble up a bit to the top. My actually preferred approach would be to put it here. So I have information. I have no function to in because this overload fails because there is no rep specified. This one fails because there is not enough arguments. And this one fails because concepts are not satisfied with exception, scaling from meter to kilometer is not value preserving for interpretation type. And then you have errors, information why this exception was thrown, which would be awesome to analyze for the users, right? Being able to specify custom error message for each overload would save a lot of time in debugging of those issues. Trying to fix those, right? This is where I hope we'll be in the next C++ language version. So we can do a lot to improve compile time error messages. Of course, Hanna also provided a paper that allows us to actually use standard exception types rather than customer exception types at compile time. So you can just inherit from logic error and have this work nicely. So this is my story of improving compile times. If you care about them already, you can make probably them much better than they are already, right now in the software you use. It's possible to improve. I just proved you how Boost compares to my library right now, right? If you have a proper mindset and you test how error messages actually look like, you can do better. But with those features, you'd be able to go one level higher with those compile time error messages. All right, let's talk briefly about safety, because we are nearly out of time, but still not many features to discuss, so we are good. For a long time, I also say that we should prevent truncation of data, right? We have some approximations stating that floating point is values preserving, and every conversion from int to float is always true, even though it's not, it's a lie. But this is the best we can do as of today. Right? This is how I write the template. I say that we should use treated floating point type trait that I mentioned to you before to verify if I'm converting from int to float or float to int, or between two floats. This is basically consistent with what chrono duration does. And it's not only my concern. Klaus Engelberger, during his keynote at using Stut C++ conference in Madrid, he also provided during his slides information that he would like to actually constrain this operator of the same as UW to prevent any kind of conversion, because conversions are considered wrong, or provide customization that only non-array conversions are needed, but you have to write this thing by yourself because there's nothing in the standard. Also, SIMD, accepted for C++26, provides in the specification that T is value preserving, even though there is no standard way to checking that. So basically, every compiler vendor will have to implement this anyway for C++26, but not expose it as a public interface. There's a proposal for a typescript called is convertible without narrowing. This would be already an improvement. However, this code will not work in my case, so I think it's not a good use case for me, because as long as I would be able to have a comparative error when I converting float to int, because this will trigger, then int to double probably should work. If it doesn't work, people will complain that it's just too constraining. Language specifies that integers to floating points is a truncating conversion, even though in most cases it's not, on most platforms. That's why there is another proposal, 2509, that detects value-preserving conversions. This is called is value-preserving convertible. Well, actually, it checks on the specification for each platform if it's value-preserving or not. And in most cases, double can represent all of the ints. Maybe not int 64Ts, but ints for sure. Right? 65,000 is not that hard for double to represent. So this should work on all of the platforms in this case. We don't have it yet. Hopefully to be accepted as well for C++29, and we'll be able to benefit from those conversions and have checks in library. However, this might not be portable because it checks for specific platform implementation of specific types rather than having the language rules for all of the types here. Text utilities. This is modern C++, sorry, this is simple legacy C++ program, right? We have cout, we have cin, cout. This is modern C++ program, right? Or not? We already have possibility to express text output, but text input still sucks. There's a nice proposal from Elias called text parsing, and it's right now he has a nice open source library called scanlib, similar to fmtlib. So it does exactly the opposite, right? With this, you'll be able to basically parse the input and then print it with exceptions or no exceptions interfaces, so everyone will be happy and you can use it nicely. Another things that are picture again, fine, all right. Another feature that's missing. Don't you think that's embarrassing that in 2025 we cannot handle Unicode or do any internationalization in the language? There is still not enough work on this one. If you care, if you work in domains that require to use Unicode, internationalization, please help. We really need those things to provide better experience to our users as well. All right? This is a big work, but all of the model languages already have it. We don't. So it would be nice to have some work on this. Finally, we want to distribute our projects properly. Who likes writing CMake config files and installation scripts? I see one hand, two hands in the audience. That's a lot. Right? You have to write those config scripts by yourself. And doing this right is actually not easy. And then provide the installation scripts for the project that people typically don't provide because it's just too complex. Right? People typically want to get things, but don't think how to propagate stuff to others in their CMake scripts. Or at least they'll not test it. Even if there's something, probably it's not working properly. There's a paper called Common Description Format for C++ Libraries and Packages. It introduces a new format called CPS. And instead of doing this and this, you will have to write in CMake only install package info, and the CMake will generate all of the package info from the scripts by themselves, and will provide you the JSON file with all of the description of your package in a JSON file. Also, if you know Conan, I love Conan. Conan is great. Use Conan, but I had to write package info. Package info typically duplicates what you already have in CMake. Every single change, every single flag, and a single branch has to be exposed in package info because it is being used to generate stuff from the Conan specification. If you are on CMake domain only, then package info theoretically is not needed because you may just use original CMake files from the project, assuming they are written correctly. But in case you want to use this package in different build systems, so the Conan has to generate scripts for them, then package info is needed. And this is really problematic in my, for example, project to write this and have it consistent with CMake files. After CPS, you will just say, just package info, just read it from the CPS file, and you will know exactly what to expose to users. And this actually will be the default, when CPS will be the established practice in the industry. So right now, when you install libraries, you just install the include files, in my case, and then you install all of those CMake scripts, so CMake file, version, and targets. After that, you will install the CPS file. And CPS file will look something like this in a JSON format. So to summarize, C++ is probably the best programming language to implement generic libraries. There's no better. It is awesome. We have zero-cost abstractions, thanks to templates, that don't affect runtime performance, that don't require us to use additional memory usage. Constraints and concepts improve interfaces. Contracts will improve safety and interfaces as well. Reflection will change the world of C++. We'll have so many new libraries, so many new use cases that we can't even imagine right now. People are really creative. But we need some help. Still, some libraries are missing. Still, some features are missing. Some more work is needed in order to provide better experience to our users. If you're an expert or just care about specific domain, like, for example, math or internationalization or Unicode, please come and help us because, well, every help is welcome. Thank you. That's it. Are there any questions?